All right, I want to go through one more way in solving systems. So if you have two different line equations, we already went through solving by substitution and solving by graphing. Now we're going to look at solving systems by elimination or also by linear combination. So first of all, I wouldn't write down all the steps. I'd only write down one of them. But as you copy that title, just want to make the comment, what are we really doing here? What we're trying to do is if we have two lines, so say this is a line and that's a line, we could get an equation for both of those lines. And then we're trying to figure out, well, what's this point right there? What's the one point that's going to work on both line equations? What's the one point that's in both lines? Okay, now for the steps, a lot of it I don't think you have to write down, except for this step number 3. I would write that. I'd probably leave off the 3. But I think it's worth writing the same signs you subtract and different signs you add. And if you want to, you could pause the video and actually go and write all the steps. But what we're going to do is we're going to try to take the equations and step one, line them up. So have the x value right above the x value in the two equations. I'll show you what that means. But then in the second step, we're going to try to get where both equations have the same x coefficient or the same y coefficient. So they'll both be like a 3x, or maybe one will be 3x and one will be negative 3x, or they'll both be 7y or something like that. And when they have that, you can take, and just like we did with substitution, you can take and combine the equations in a way that now just gives you one equation with one variable. Then you can do step number 4, solve for that variable. And then step 5, figure out the second variable. And then step 6, that often we skip in real life, is check your answer. So do pause this, maybe write down same sign subtract, different signs add, and then we'll just jump right to our first example. So my first example is going to be this system. So I'm going to have 3x minus 5y equals 11. Then I'm going to have a 6x plus 5y equals 7. And I try to make sure that you're caught up with me right now. So if you're copying something, quick pause it and then copy this down. All right, now what we do is we want to get an equation where we just have one variable. And what we could do is, well, I have negative 5y and I have positive 5y. So step 2 is already kind of done for me. And from there now, if I want to get those y's to drop out, so I just have an equation with an x in it, I could take and add those. Because a negative 5 plus a positive 5 just gives me 0 of the y's. And I wouldn't actually write that down, but want to just kind of show what happens there. But if we could add the y's together, we also have to add the x's together. So 3x plus 6x gives me 9x. Like I said, negative 5y plus 5y just drops out, so that's gone. 11 plus 7 gives me 18. Now we have an equation with one variable. If we want to solve that, all we have to do is divide both sides by the 9. So divide both sides by 9, and I end up with my x value has to be 2. And now that we know x is 2, we just did step 4, so now step 5, we want to find the other variable. So we could pick whatever equation looks nice. I'm probably going to go with the second equation. It's positive. I like the plus in there. So if I take and put a 2 in there for x, I end up with a 6 times a 2 plus 5y equals 7. So 12 plus 5y equals 7. From there I could subtract 12 from both sides, and I get 5y equals negative 5. And then divide both sides by 5, and I have a y equals negative 1. So what we just found is, if I would graph those two different lines given by the equations here at the beginning, this equation, that equation, the point that they have in common is 2, negative 1. So that'll be the final answer. 2, negative 1 is the solution for that system. So I want to quick do a second example here. I wouldn't copy this down. We're going to save a little bit of time and not actually go through the whole thing. But if we were to have a situation like this, it might be tempting to go through and kind of add like we did before. But if you look here, I have a 3y and a 3y. If I were to add those together, I'd get 6y's. If I were to add my x's together, I'd have a 3x, and then I'd have a negative 2. So it does us absolutely no good to add those two equations together because neither the x's nor the y's drop out. That's kind of what I'm getting at up here, that before when we had a positive and a negative, the different signs, we added them together, they dropped out. Now if I have a positive 3y and a positive 3y, adding isn't going to take and make those things drop out. but I could subtract, and that's what I meant by same sign subtract, that I have the same positives here, so I need to subtract those two. And you'll see now, if I change that to subtraction, and again, I wouldn't bother doing this, but a 8x minus a negative 5x becomes 8x plus 5x, so I'd have 13x's. And then a 3y minus 3y just gives me 0 y's, that drops out. Negative 4 minus 2 gives me a negative 6, and then I could go through and work through the problem from there. All right, this next example I think we should all write down, so this will officially be example 2. So I have one equation is going to be negative 6x plus 2y equals a negative 22. My second equation, my second line, will be 3x plus 3y equals 27. And a lot of this is keeping organized, that the people that are sloppy tend to struggle a little bit more with getting these right, I've found. So this is a way that I found to kind of do these ones. So first I look at it and I see, all right, I'm not going to be able to have x's or y's cancel out if I add those two together or subtract those two because my x coefficients aren't the same. I have a negative 6 and a 3, and I have a positive 2 and a positive 3 for the y, so the y's aren't the same. So you first need to figure out what do you want to have drop out. You could take the y's and change them both to 6y, or maybe one to positive 6y, one to negative 6y. But to me, these are kind of screaming, cancel me out, because I only have to change my bottom equation. I could real easily make this a 6x. So I got in the habit of writing it this way when I was in high school. I think staying organized is key. I'm just going to put a little arrow, say I'm taking this equation and changing it. And since I'm really not doing anything to this one, I'm just going to write in negative 6x plus 2y equals a negative 22. Now my bottom equation, I want to cancel out my x's, so I need that to be a 6x. So what do I multiply 3x by? I have to multiply that by 2. So 3x times 2 gives me my 6x. And kind of keep it all nicely lined up. But to keep it equal, that's kind of what I was talking about here with the multiply all parts of one or both equations to get the same x or y coefficients. That to keep this equals here, you have to do 3x times 2, positive 3y times 2, and 27 times 2. So positive 3y times 2 gives me a positive 6y. 27 times 2 gives me a 54. And now we could go and work through the problem just like before. That to get these x's to cancel out, I can't subtract, so that would give me a negative 12x. But different signs, I add them, and I get 0 x's. Add my y's, I have 8y. Add my constants over here, and I get a 32. So now if I were to go through and divide both sides by 8, I have a y equals 4. And now once I have y equals 4, I could take that and I could really put it into any of these equations. I'm going to put it in right there just because it has the smallest numbers and everything's positive. So 3x plus 3 times 4 equals 27. Now this will help me find the x value. So I have 3x plus 12 equals 27. So I'm going to go through and subtract 12 from both sides. And I get 3x equals 15. Divide both sides by 3, and x is 5. So the point where those two lines cross is going to be 5, 4. I want to do one last example, and we're not going to actually work through the whole thing, but want to say here's a story problem. How do you get the equations? And then show getting them to a point where you'd be able to cancel them out. So I have 5 candy bars and 7 pops cost $26. 3 candy bars and 2 pops cost $9. What is the cost for a candy bar and the price for a pop? Like it's pretty true with story problems, is what they're really trying to find is at the end of the question. So we're going to have the cost for a candy bar and the cost or the price for a pop. And you could go through and use variables of C and P for candy bar and pop, but I'm just going to go with X and with Y. So the cost for a candy bar is going to be X, the cost for a pop is going to be Y. So you need to take these two things here and turn them into equations that we can manipulate. So 5 candy bars, well if each candy bar costs X, 5 times X is going to give me the total cost for candy bars. 7 pops, so if Y is the cost for 1 pop, 7Y is going to give me the total cost for 7 pops. So to combine those, we'd add them together, and then that should give us $26. Now for that second one now, we could say 3 candy bars and 2 pops cost $9. So if X is the cost for a candy bar, I could say 3X plus 2 pops, well that's going to be 2 times y, and we have $9. And now we're in a situation where neither the x's nor the y's will cancel out. We could go and multiply by a decimal and just change one equation. So I would recommend instead, let's just go and change them both. And so far I've been having my x's drop out, but let's have the y's drop out this time. So I'm going to say take that top one and multiply it by 2, then take my bottom one and multiply it by 7. So that'll get us up to where we have 14 y's, and then we'll be able to cancel them out. So 5 times 2, or 5x times 2 then, would give me 10x. And 7y times 2 gives me a positive 14y. 26 times 2 gives me 52, or equals 52. Now for my bottom equation, I multiply by 7, so I get a 21x. Then I get a plus 14y equals 63. And once we're this far, we just need to say, well, how do I combine those in a way that are going to make my y's drop out? And in doing that, they're the exact same, so I need to subtract, because 14y minus 14y is going to cancel out the y's. So I'd end up with a 10x minus 21x, so negative 11x. And a 52 minus 63 would give me a negative 11. And I could go from there, find x, and then once I have my x, I could find my y. So you can quit the notes here at this point if you want to. I'm going to finish it just out of habit and principle. But I could divide both sides by negative 11, and then x has to be a 1. And once I know my x is 1, I could take and put it in there. 3 times 1 is 3, plus 2y equals 9. Subtract 3 from both sides, and I get a 2y equals 6. So then y has to be 3. So final answer is going to be the point 1, 3. So this way to solve problems works best when you have neither equation being solved for a variable. I do this instead of the solving by substitution.